So here's a very simple diagram of what a complex event processing application looks like. You've got events coming in from the left into a construct called an adapter, whose job is very simple. It's to understand the protocol and transport of the incoming event. Typical event transports could be HTTP. You could have XML. You could have a socket. You could have a flat file. Really doesn't matter. You could have very specific industry protocols. The job of the adapter is to translate that into a common format. And in our case, the Oracle Complex Event Processing product, we translate those incoming events into a plain old Java object and pass it into what we call an event processing network that all operates in memory at extremely high speeds. Now that event is going to pass over something we call a channel. For more technical users that want to have fine-grained control over thread allocation and want to be able to do sort of internal fine-grained load balancing, a channel can offer that kind of tuning. The job of the channel is to route the event from the adapter to the processor, and then from the processor back out to an outbound adapter. And the processor is where we implement queries on those incoming events as a stream. And in our case, we use a language called CQL for continuous query language, which is SQL 99 compliant. It's in the process of becoming a standard, and it allows people familiar with SQL to apply very similar, if not identical, set of queries, same kind of technology, same kind of logic. But now instead of doing it on a database table, you're doing it in real time on events as they're coming into the processor.
Peter, we'll need to wrap in about 3 minutes so we can fit Randy in as well and have a,
All right,
couple of questions.
Well, we'll keep going. Key point I want to make here is that we're able to use state data from both distributed cache and local cache. Most events being processed in real time need extra context. You need to be able to have data present in memory as opposed to having to go out to a database in order to maintain the high speed. And the next slide. So in terms of implementation, there are really three categories of characteristics that we think are important for a CEP tool. You need to have a lightweight platform to run these applications in. You need to have supporting event processing infrastructure and a development environment that enables you to construct these with familiar tools. And you need to have some non-programmatic web-based authoring and management tools. I've got some technical details in here that people might recognize. In Oracle's case, we've got a specialized OSGI-based server. We determined that J2EE was too slow to handle the kinds of volumes that we wanted to pass through. I'll skip over most of this. One I mentioned before, the tight integration with local and distributed cache, and it's also really important to have tight integration with functions like geospatial functions for tracking things that are reporting, for instance, GPS coordinates. You need to have access to sophisticated mathematical functions. You need to be able to easily integrate with your own functions. And you need to be able to, as I said, have some web-based tools for those people that don't want to write a lot of code. Next slide, please. Here are a couple of screenshots showing the tools that are associated with Oracle's product. We have tools for constructing flows with using a graphical authoring tool. We're able to monitor performance, throughput, and latency at various points in the flow. A very important feature that you need in order to be doing simulations is being able to record events at a particular spot and play them back later on to do what-if scenarios. And we also have the ability here to control your deployments, to manage clusters, the kinds of things you normally expect in data center deployments, but focused in particular on the CEP tools. Next slide. So Jesse asked me to close up with some real-world success tips. I think a lot of these are sort of mom and apple pie, but the protecting your business logic, I map back to Jesse's comment about the observability strategy. It's really important as you're thinking about protecting and maintaining the business logic that you've been using for years. Most of that logic still applies, even though there's 1,000 times as much data coming at it. So if you can figure out a way to filter the data up front, understand simple operations generally that you can do very quickly. Some events are critical and need to be passed straight through. Some can be correlated to generate secondary events. Some events can just be ignored or set up into a staging area to be processed later. I think it's really important to make sure that any architecture you're planning on adopt is able to be highly available. You want to understand what's the maximum throughput that's going to hit your application, and then figure out where deploying CEP will get you the most bang for the buck. And you want to be able constantly to monitor and measure the system performance. And as you're measuring, you want to be able to do simulations, measure what happens, do record and playback, and just be able to follow through the cycle of prototyping and tuning. So that's pretty much my presentation, Jeff.
Great, Peter. That's terrific. Thank you very much. Interesting question from one of our attendees saying, please help me understand how SCADA systems and CEP work together.
So CEP is a generic tool for handling events from any data source. So applying the events, CEP is capable of opening up, as I said, event ports. Whether or not CEP would be deployed directly to a SCADA system or on the inside of some other mechanism, I think would depend on the architecture.
Okay. Another question, to correlate data you need timestamps. What is going to provide the heartbeat or the timing?
Well, the timestamp can be on the incoming event and can be preserved through the logic. We also put a timestamp on the event at the moment that it arrives. So you're going to have both times associated with any event that's moving through the network.
We also had a question about, are there off-the-shelf applications available that take advantage of CEP but also tap into or handle some of the sort of standard or legacy applications like AMI?
I think Jeff might have a better sense of that across the industry. At Oracle, we're definitely looking at ways to take our business applications and our technologies like CEP and put them together. We aren't offering any merged product today.
Peter, thank you so much. Very helpful.